Vector overlay includes a lot of GIS operations, including clip, intersect, union, and erase. Vector overlay also depends on rebuilding topology. So what we mean by this is we might have two polygon layers, such as this top layer here, which has three different polygons, 1, 2, and 3, and this other polygon layer here, which has two different polygons, 1 and 2. We want to combine those two into a new polygon layer, but we don't just want to display them on a map. We want to combine them such as every time two lines intersect here, we break those two lines here, we put in a new node, and we create a new polygon that wasn't there before, like this polygon number 5. This polygon number 5 is not only going to be its own polygon now, but it's going to now have its own row in the attribute table, and it's going to have attributes from both this layer and from this layer here. So when we do these vector overlays, the attribute tables tend to get much longer, and we tend to get a lot more polygons. And there's no way of predicting how many more polygons we're going to get. It just depends on how intricate and how many times these other polygon lines cross over each other. Let's take a look at an example here. Let's say we have this geographic layer here with polygons 1 and 2, and we have this one here with polygons 1 and 2. When we combine those two in an overlay type of analysis, now we would have 4 different polygons. So we've gone from 2 polygons that each have two features in the attribute table and 1 attribute. Now we have 4 features in the attribute table, 1 through 4. We preserve class from this layer 1, and we preserve cost from this layer 2, and now we have a much longer attribute table as well after we've done this vector overlay. One type of vector overlay that we often use is called clip. You can think of the clip layer sort of like a cookie cutter, and the input layer sort of as the dough. So we're taking this cookie cutter, we're putting it over the dough, we're cutting out a piece, and that's what the new layer is going to be. So if you have a map of a much bigger area like the United States, and you just want to clip out a smaller area like the state of Oregon, you could use clip in order to clip out that data, those GIS layers. And remember, you're actually making a new GIS layer here, this output layer, which would be the clipped layer. Here's an example where we have a number of counties selected, and that's going to be the cookie cutter, and the dough is going to be all of these watersheds over in this map here. So we don't want all of these watersheds, we just want the ones within the bounding area of these counties that we've selected here. So we apply the cookie cutter over here, and then we cut out just those areas. They're no longer complete watersheds like these ones over here, but they're ending at these county boundaries, which are the clip layer. Somewhat similar but different than clip is intersect. With intersect, we have 2 different GIS layers, and the output is only the area in which those 2 layers overlap. So we can see one of our input layers is here, our other input layer, intersect layer, is this yellow circle here, and the output that we would get would be the portion of the yellow circle that's above this line here, and then everything below this portion of the circle that came from the blue layer there. So in this case here, we would intersect those 2, and we would get these 2 new polygons here. Typically with intersect, we get smaller outputs than we would with some of these other methods, such as union, that we'll talk about in a minute here. As an example of intersect, here's once again the watersheds. We're intersecting that with the counties, and now we can see that we've still got the same boundary as we did with clip, but now we also have internal intersections that are going on here, like this area between Hennepin and Anoka County. It's still there, but it's also overlaid with all of the watershed boundaries in this area here. So this could be more useful than a clip if we wanted to know what portion of this particular watershed was just the responsibility of, for example, Hennepin County, because all of the information from both of those layers would be included in the output attribute table. Another type of vector overlay is union. And with union, we're basically combining the 2, but we're also making new polygons based on where all of the line intersections are. So here nothing is lost. We still get both of the entire areas of the input layers, but now we go from 1, 2 polygons in the gray layer and just 1 polygon in the yellow layer to now we have 1, 2, 3, 4, 5 new polygons that would be in the output layer. And each of those outputs, each of those new features would inherit all of the attributes from both the gray layer here and the yellow layer, so we'd expect that attribute table to be much larger as well. This would be an example of the union command. So in this union command, we have the catchment once again and the counties. But when we do the union, we don't lose any of the watersheds outside of that county boundary. Those are all still preserved and they're not really very much affected. But inside of that county boundary, inside of this outline here, now we're starting to carve things up. We're taking into account all of the lines that represent boundaries between the watersheds and all of the lines that represent boundaries between the different counties. And we're slicing and dicing that so that we can see here, for example, this is partially based on a watershed, this red area here, and it's partially based on a county boundary. That would be its own new feature, and it would have all of the attributes of both the watersheds and the counties in its attribute table. Another type of vector analysis is erase, and this just kind of erases or gets rid of some of the area that we're not interested in. So in this example here, we start out with counties, and then we take a watershed or a catchment that partially overlaps this entire area here, and we're not concerned with that watershed or the counties within that watershed. So we just kind of cut away all of the area that represents this outline here so that we're left with the counties that are not within that catchment or watershed. And so we can see here we've combined the two. We're using this to cut away everything along that gray-yellow line there, and then all of the yellow material, all the stuff overlapping with yellow material is removed so that now the counties are shown here. In some cases, we just get parts of counties. We get little pieces of counties here. That's not the entire county, but that's what erase is designed to do. With all of that going on, one thing to keep in mind is sometimes the boundaries of things don't match exactly. So for example, in this case here, maybe two adjacent counties tried to get their boundary to match, but when they were digitizing it, there were some variations between this kind of jaggedy, edgy line here and this smooth, curvy line shown in this area here. In that case, when we, for example, intersect or union these two, we might get a lot of little polygons that really aren't of interest to us. We really don't care about these because these two boundaries should be right on top of each other, but they're really not. These can sometimes cause an issue in GIS, and these are typically called sliver polygons.